Sir Chester, were you able to see my screen?
Hindi.
Oh no. Wait, let me just figure it out. Everyone, please bear with us po. We're trying to fix some technical issues. All right. I guess magandang araw po sa inyong lahat. Ako po si Jeffrey Bunkin, founder of Filipino Science Hub. So, we welcome you all po sa session natin ngayong araw na ito. And pagpapatuloy po natin ang ating chemistry essential skills. Ito po ang ating second installment at ang ating pong webinar for today will also feature Dr. Chester Dabalos from the University of Hawaii. And this time around, Sir Chester will focus on quantitative skills, and what makes this webinar very special is that he is contextualizing this skill on a very important and a highly dreaded topic, which is stoichiometry. And so without further ado, I would like to share with you, or I would like to give the floor to Dr. Chester Dabalos. Sir Chester, take it away.
Aloha, magandang umaga po sa inyong lahat. Salamat po sa patuloy na pagsubaybay at pagtangkilik sa webinar ng Filipino Science Hub. Yes, sabi nga ni Sir Jeffrey, naisipan namin na nabigyan na mag-present ng topic on stoichiometry kasi this is actually one of the most dreaded subject, I mean, among high school and college students alike. So sa pagtuturo ko sa kolehiyo, nakita ko talaga na una, I mean, kung wala pang stoichiometry, ang tataas ng nakukuha ng mga estudyante. Tapos pag dumating kami sa stoichiometry, I mean, talagang bumababa ang kanilang mga performance. So ngayon, ang gagawin ko po is i-share ko sa inyo ang aking mga insights on how to deal with stoichiometric problems. Okay, so okay, so uh, okay, so again, welcome po sa inyo sa lahat ng mga tagapagsubaybay. So ngayon, i-discuss ko na po ang calculations in stoichiometry. So magbibigay ako ng analogy ng stoichiometry. So first, stoichiometry is defined as the measurement of quantities or ratios of elements. Pero pag pinakinggan mo tong definition na to, I mean, it is very it's a mouthful of words, okay? Para bigyan i-contextualize ang stoichiometry, magbibigay ako ng isang magandang analogy. So gusto ko sa aking presentasyon, ang iisipin nyo lamang ay actually recipe, okay? Actually, I mean, ang stoichiometry really is a recipe. So makikita natin, say for example, kung meron tayong isang chemical formula, okay? So so ang example ng chemical formula is kunwari ito, C12H22O11. So kung matatandaan nyo, I mean, this is actually table sugar or sucrose. So sa chemical formula, okay, makikita natin na may specific recipe ang isang molecule ng sucrose. We are going to describe that later in detail mamaya. Okay? Tapos, ang isa pang mahalagang component ng stoichiometry is the balanced chemical equation. Okay? So take note, balanced chemical equation. So say for example, may balanced chemical equation ako dito. Okay? So CaC2 plus 2H2O to give you C2H2 plus CaOH2. Okay? So yung balanced chemical equation ay isang recipe din. So say, pwede natin sabihin na may 1 mole of calcium carbide, 2 moles of water, 1 mole of C2H2, and then 1 mole of calcium hydroxide. So recipe din yun. So again, really, ang stoichiometry is going to be recipe. Okay? Ang bida sa sa recipe na ito will be mole. Okay? So syempre, kung chemist ka, hindi mo naman sasabihin say paksa or kutsarita or kutsara or palanggana. Ang unit of measurement na ginagamit natin ay kadalasang mole. Okay? Kung tandaan nyo pa, this is actually a fundamental unit, okay, stating the amount of matter. Okay? So related sa sa concept ng mole, makikita natin yung mga units related to that, okay? To say ang una diyan is your molar mass, okay? Gram per mole. So ang ginagawa ko pala ngayon is I'm just giving you an overview. Ang gagawin natin mamaya, so overview muna, parang bird's eye view, tapos i-zoom in natin. Gusto ko kasi nakikita nyo muna yung yung general picture, tapos titignan natin yung details, okay? So, yung molar mass, gram per mole, syempre yung mole nandiyan, okay? Tapos kung may gases naman tayo, okay, alam nyo to mga high school teachers, say PV equals nRT, the ideal gas equation. So makikita natin dito yung N, okay, is going to be the number of moles. Ito lamang, tong equation na ito ay para sa mga gaseous species lamang. Tapos yung panghuli na gusto kong i-discuss, okay, na may mole, na may unit mole is going to be the unit of concentration molarity. So moles per liter. So syempre nakikita nyo na may moles diyan, okay? So ito po yung general overview ng gusto kong i-discuss ngayon. So magkakaroon tayo ng tatlong problems. So the way that I'm going to do this is i-review ko muna yung mga concepts na kailangan para i-answeran yung problem na yon. Tapos we will state the problem. Tapos tapos na ganyan titignan natin yung solution. Okay? Okay. Okay. Oops. Teka, saan na yung next? Give me a moment. Wait. Sorry. Saan yung... Teka, paano pumunta sa next? So, to enter.
On your keyboard, arrow right.
Arrow right. Okay. Ayaw.
Click on your mouse.
Mouse. Okay. Yun, sorry. Pasensya na kayo. I mean, I came from an older generation. So, okay. So, gusto ko rin sa sa mga problems na gagawin natin, I would like you to remember, okay, yung ginawa natin yung first session. So, I'm actually expecting na matatandaan nyo yung airplane and ship methods, okay? Pero ang gusto kong i-highlight dito sa airplane and ship methods na kailangan natin sa sa stoichiometric calculations will be yung number 3 ng airplane, okay? So gusto kong i-emphasize yung present ng given then required, okay, using unit analysis, okay? So one, highlight dito sa airplane and ship methods na kailangan natin sa nag-e-echo ata. So, tapos ng ganyan, tapos syempre yung principle, okay? And then yung number sense. Mahalaga yung number sense kasi parang alam natin kung tama ba yung strategy na ginawa natin. Tapos yung panghuli na gusto kong i-emphasize is yung matatagpuan sa ship, okay? So I'm going to give you a pattern in order to actually look at a certain problem. Tong pattern na to will be in a form of a flow chart or what we call as a concept map. So makikita nyo mamaya parang diagram siya, map. It's going to actually tell you, I mean, yung progress ng calculation. So at a given point, makukuha mo ito. Tapos kung pupunta ka na naman sa sa next point, ayun, so nata-track mo yung progress. Okay? Okay. So ang gagawin natin ngayon is magbibigay na tayo ng details ng ating mga concepts. Okay, yung una kong ipapaliwanag sa inyo is yung concept ng chemical formula. Okay? So chemical formula, kung meron kang chemical formula, ang chemical formula will tell you the ratio of those elements in a given compound. Okay? Pero inisip nyo masyado naman very chemistry. So bigyan natin ng cultural context ito. So syempre malapit na ang Pasko, kaya ang example ko ay something that is very special to us Filipinos. So I know kung Pasko, I mean siguro lahat ng bahay, I mean sa kanilang bintana ay nagsasabit sila ng parol. Okay? So tignan natin tong parol na ito. Okay? So ang isang parol, okay? So picture on your left, okay? So makikita tayo ng isang bituin, isang star, okay, na may 5 rays, okay? Tapos kadalasan may wreath ito, yung pinapalibutan niya yung star. Tapos ng ganyan, may buntot. Usually dalawa yung buntot ng parol. So sa isang parol, may isang bituin, may isang wreath at saka may dalawang tail. Okay? So kung from this point, nakikita nyo na may recipe yung parol. Isn't it yung sinabi ko kanina, ang stoichiometry is really a recipe. Okay? So, balik tanawan natin yung pinakita ko kanina, yung table sugar or sucrose. Okay? So, yung formula ng sucrose is C12H22, C12H22O11. Okay? So, ang isang molecule, okay? So, kung meron kang chemical formula, may dalawang interpretation ito. So, una, yung tinatawag ko na microscopic interpretation. So, ano nga ba itong microscopic interpretation? Okay? So, yung kung microscopic, hindi mo nakikita. Okay? So, kung pwedeng, ang interpretation nito is in terms of molecules and atoms. Okay? Halimbawa, yung chemical formula ng table sugar, C12H22O11. So, ang isang molecule ng sucrose, yung table sugar, ay nagko-compose ng 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. Okay? So kung makikita nyo sa picture, so yung gitna, okay? So yung carbon atoms, yan yung gray na balls, okay? So kung bibilangin nyo, may 12, okay? May 12 na carbon atoms. So ipapakita ko lamang. So okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So may 12 carbon atoms, okay? Per molecule of sucrose, okay? Tapos meron kang 22 hydrogen atoms. Masyado silang marami ata. So yung puti, tapos may 11 oxygen atoms yung pula. Okay? So yan yung microscopic interpretation, molecule atom. Okay, molecule atom level. Meron naman tayong tinatawag na macroscopic interpretation. Pag sinabi mo macroscopic, ito ay nakikita mo. Okay? And usually itong macroscopic interpretation, ito ang ginagamit sa stoichiometry. Okay, so ano nga ba itong macroscopic interpretation? Okay? So yung macroscopic interpretation, ang bida dito is actually yung mole. Okay? So again, microscopic molecule atoms hindi mo nakikita. Yung macroscopic po pwede mo makita. Actually, yun yung mole. Okay? So ang 1 mole ng C12H22O11 or sucrose is actually made up of 12 moles of carbon, 22 moles of hydrogen, and 11 moles of oxygen. Okay? So again, kung macroscopic, okay, yung pinag-uusapan, ang unit na tinignan natin is yung mole, yung bida sa stoichiometry. Okay? So again, 1 mole of C12H22O11 will be composed of 12 moles of carbon, 22 moles of hydrogen, and 11 moles of oxygen. So yan yung review natin o pagbabalik tanaw sa chemical formula. Okay? So, meron kayong tanong at this time? Sabihin nyo lang kung meron kayong tanong, po pwede ako mag-stop to address your questions, or kung hindi naman, po pwede nating i-reserve towards the end of the discussion. Okay? So yan yung chemical formula. Review pa lamang yan. So ang next na titignan natin is ano nga ba itong mole na ito? Ang mole, again, as I mentioned kanina, is actually the one of the fundamental units, okay? And it actually tells us the amount of matter. Okay? So mole concept, okay? So pag sinabi mong meron kang isang mole, okay? Ang pinakamabilis na interpretation dito is actually hanapin natin, bumalik. Okay. Ang pinakamabilis na interpretation dito is actually tignan natin yung periodic table of elements. So say for example, puntahan natin yung carbon, okay? So isn't it sanay na kayong nakita na yung carbon, okay, sa ilalim ng carbon nakita natin 12.011. So anong ibig sabihin nito, okay? So for elemental form, ang ibig sabihin niyan is 1 mole of carbon is going to weigh about 12.01 grams. Okay? So say for example, tong balance na ito may about 12.01 grams of carbon. So lahat so itong quantity na ito tells you that you have 1 mole. Again, ang sinabi ko kanina, mole is actually something macroscopic. Nakikita mo yan. Okay? Nakikita mo ang mole, pero hindi mo nakikita yung atom. Okay? So, yun yung interpretation ng mole for a very simple element. Okay? Paano naman ngayon kung meron ka ng compound? Okay? So say meron akong very complex formula dito. Okay? C28 H31 Cl and 2O3. Ang haba naman ng pero gagamitin natin yan mamaya. Okay? So, kung meron formula this complex, dito pumapasok yung concept ng molar mass. Okay? Ano nga ba tong molar mass? Okay? Pag sinabi mong molar mass, it's actually the mass, okay, of 1 mole of that substance. Kaya nga tinawag na molar mass. Molar, modifier yun, parang adjective, tapos mass yung noun. Okay. So, paano natin i-compute yung molar mass at paano natin i-interpret yung value na nakukuha natin sa molar mass? Okay. So, C28H31Cl and 2O3. So, ang una natin gagawin dyan is kukunin natin yung mga subscripts. Okay, so say for example, 28 carbon, 31 hydrogen, 1 Cl, 2 of nitrogen, and 3 of oxygen. Kung maalala nyo kanina, ano yung interpretation natin ng mole? So, 1 mole of C28H31 Cl N2O3. Ang ibig sabihin yan is that 1 mole of that compound is made up of 28 moles of carbon, 31 moles of hydrogen, 1 mole of chlorine, 2 moles of nitrogen, and 3 moles of oxygen. Okay, so parang may multiplier yun, di ba? Okay, so since may multiplier, so ang gagawin natin is for carbon is going to be 28, di ba? 28 moles times 1 mole is going to be 12.01. So that's going to be 336.28. Tapos gagawin natin the same thing sa rest. Okay, so 31 hydrogen, tapos pupuntahan natin yung periodic table of elements. Okay, under hydrogen, meron kang 1.008. Okay, so that's actually the average. Okay, at average AMU. Okay, so 31 times 1.008 is 31.248. And then, since nakita nyo na yung pattern, okay, i-multiply nyo itong mga values na to. Tapos yung mga product na makukuha, okay, we are going to simply add them up. Okay, so pag in-add natin yan, we are going to have 479.0 grams per mole. So nang ibig sabihin ng value na ito? So sinasabi ko sa mga estudyante ko, dapat huwag kayong kontento in order just getting a value. Dapat alam nyo yung interpretation ng value na yon. Ang ibig sabihin nito, kung meron kang 479 grams ng compound na C28H31 ClN2O3, ibig sabihin meron kang 1 mole. Okay? 1 mole ng compound na yon. Kung meron kang 239.5 grams, ibig sabihin meron kang kalahating mole. Kung meron kang 160 grams, ibig sabihin meron kang 1/3 na mole. Okay? Yun lang ang ibig sabihin ng molar mass. Okay? So, I hope na na-review nyo tong important concept na to. And sabihin nyo rin sa mga estudyante ninyo na in all stoichiometric calculation, dapat tama ang molar mass. Okay? Nasabi ko sa kanila, sa stoichiometry, dapat tama ang molar mass at saka tama yung balanced chemical equation na i-discuss natin later on. Kasi pag pag meron ka lang isang mali, lahat na ay mali sa stoichiometry. Okay? So napaka-unforgiving talaga ng science. Okay? May isa pa akong concept na gustong i-review before nating i-reveal yung first problem. So this actually pertains to the Avogadro's number. Mahalaga ang Avogadro's number sa mole concept. Okay? So Avogadro's number, ano nga ba tong Avogadro's number? Bibigyan ko kayo ng a little snapshot on history. Itong Avogadro's number na to ay natuklasan ito sa pag-study ng gases. Okay? So Amadeo Avogadro, isa siyang Italian chemist. Okay? So natanto nila na tong Avogadro's number, okay? So is 6.02, okay? Times 10 to the 23rd particles. Okay? So, pag meron kang 6.02 times 10 to the 23rd particles, meron kang isang mole. So, teka, siglit lang. Okay, so kung meron kang 6.02 times 10 to the 23rd particles, meron kang isang mole. Now, question, ano nga ba tong particles na ito? Pag sinabi mong particles, okay, maraming po pwedeng may multiple meanings ito. Pag tinukot mo ang particles, it may mean na it could be a subatomic particle like an electron, like a proton, or like a neutron. Pwede rin naman na ito ay mga ions. Say for example, Na+, Mg2+, pwede rin namang mga atoms katulad na sinabi natin kanina, okay? So, say yung carbon atoms, okay? Pwede rin atoms, okay? Tapos pwede rin ang molecules, okay? So, maraming ibig sabihin ang particles, okay? So, again, pwedeng subatomic particles, pwedeng ions, pwedeng atoms, pwedeng molecules. Something that you cannot see, okay? So particles is something that you can see. So hindi po pwedeng grams kasi nakikita mo yung grams, okay? So yung Avogadro's number actually together with molar mass constitute a very important, okay, part in stoichiometric calculations. Okay. Now, kung maalala niyo kanina nagbanggit ako ng flow chart or concept map. Okay? Ano nga ba tong concept map na ito? So, pag sinabi mong map, ano ang map? Parang GPS, So, pwede yung sabihin kung ano yung location mo. Okay? So, mahalaga tong nakikita nyo sa ilalim. So, ito yung concept map in order to show the conversion of a gram quantity. Okay? So, a gram quantity, okay, going to moles. Okay? And para ma-convert mo yung gram to moles, kailangan mo yung molar mass. Ano nga ba yung unit ng molar mass ulit? Grams per mole. Okay? So kung nakikita nyo, ito nga yung tamang conversion factor kasi may grams ka dito, may moles ka dito. Syempre yung nasa gitna, dapat may grams at moles din. Okay? Tapos, yung moles, pwede mong i-convert to to the number of particles. Okay? In order to convert the moles to the number of particles, nangangailangan tayo ng Avogadro's number. Okay? Tandaan nyo, atoms, molecules, they are all, it could all they could mean particles. Okay? So sa flowchart na to, nakikita natin na hindi po pwede pumunta from grams to atoms and molecules agad-agad. So hindi po pwede yan. Okay? Anong analogy nito? So, di ba maalala nyo, say for example, meron kang Fahrenheit to Celsius to Kelvin. Parang ganon. So, walang direct equation that's going to convert you from Fahrenheit to Kelvin. So, wala yan. Okay? So, kailangang dumaan sa moles. Okay? So, all stoichiometric problem needs, okay, to get through moles. So sabi ko nga kanina, yung moles yan yung bida, okay? So hindi mo po pwedeng etsapwerahin yung moles. So yan yung parang Miss Universe natin. So kung sinusubaybayan niyo si Michelle D, I mean she is actually doing very well. Okay? Okay, so I mean we have enough review to go to our first problem. Okay? May tanong kayo before natin tignan yung first problem? Are all the concepts understood? Mukha naman. Kung hindi man, tanungin nyo na lang ako mamaya after ng last slide. Okay? So punta tayo sa first problem natin. Okay? So problem number 1, from moles, okay, to atoms. Actually, may typo. Dapat grams to atoms yan. Okay? Okay, so I will state the problem. So the dye, rhodamine B, actually yan yung mahabang formula na na kinalculate natin yung molar mass kanina. Okay? C28H31Cl N2O3, a component in making red gulaman, is a potential carcinogen. Okay? So, yung ginagawa ko ngayon is, syempre, I mean, I would like to use something that we have encountered. So, just to tell you, okay, anything that is colored, wag nyong medyo i-regulate yung usage na yan kasi those are actually potential carcinogens. Okay? So calculate the number of nitrogen atoms, okay, present in a teaspoon of the dye. Okay, so say for example, meron kang kutsarita na dye, 1 teaspoon will give you about 5.7 grams. Okay, tapos usually sa mga problems na to, ilalagay na natin yung mga molar masses ng elements, okay, para i-compute na ng mga estudyante. Pero we have actually solved the molar mass of the rhodamine B kanina. Okay? So, i-recall na lang natin. So, that's actually 479 grams, okay, per mole. Okay. So, again, in order to teach this concept, I mean, sa mga first timer, it would be nice to actually use yung flow chart. Okay? So, ano yung flowchart natin? So, meron kang grams to moles and then atoms and molecules. Okay. So, umpisa na natin. So ano yung required? So, calculate the number so yung given natin is actually a teaspoon of the dye. Okay, given yun. Tapos yung required is the number of nitrogen atoms. So kung tandaan niyo nung nag-problem solving tayo, karamihan sa mga problems are actually unit analysis lamang. So unit analysis is tells you that, say for example, ito yung given mo, grams. Tapos ang required mo is actually the number of atoms of nitrogen. So ang unit analysis is that you just actually play with the units, okay? So that magka-cancel yung mga units na ayaw ninyo. Tapos ang lilitaw na lang towards the end is actually the units that you like. So Yan yung concept na given, tapos required. And all along the way, you will just be using conversion factors. Okay? So in order to solve this problem, kailangan i-emphasize natin yung units sa mga estudyante. Ang observation ko kasi ngayon, nagsosolve yung mga estudyante ng isang problem, hindi nila nilalagay yung units. Actually, putting units would facilitate in solving the problem at saka makikita ninyo kung may mali sa operation. Kung hindi hindi nagtutugma yung mga units. Okay, sorry. Okay. So next, okay? Ano nga ba yung gagawin natin sa unit analysis? Sa unit analysis, meron tayong tinatawag na conversion factors, okay? So first, yung grams, okay? I think I need to use a different color here. Or maybe I just have to, okay, so, okay. Tinanggal ko na lang, okay? So first na gagawin natin is i-convert natin yung grams to moles, okay? But in order to do that, kailangan natin yung conversion factor na molar mass. Okay, ano nga ba yung molar mass kanina? 479.0 grams per mole. Okay? However, as is, hindi natin po pwedeng i-multiply yung 479 grams per mole. Okay? Kailangan i-multiply natin yung reciprocal. Okay? So yung reciprocal will be 1 mole of rhodamine B divided by 479.0 grams of rhodamine B. Ba't kailangan yung reciprocal? Siyempre, para mag-cancel yung grams. Okay? Hindi mo po pwedeng i-multiply yung grams per mole kasi pag ginawa mo yan, ano magiging unit mo? Grams squared per mole. Okay? Hindi naman, wala pa naman at kayo na-encounter na unit na ganyan, di ba? Okay. So, at this point, okay, meron ka ng moles, okay, ng rhodamine B. Okay. Pero ang tinatanong sa problem, ilang atoms, okay? Ilang atoms ng nitrogen. So kailangan magkakaroon ka ng relationship ng rhodamine B moles to nitrogen muna, di ba? Saan natin makukuha yung stoichiometric relationship na yan? Yung recipe na yan? Siyempre sa chemical formula. Hindi ba ang ibig sabihin ng chemical formula na yan is that 1 mole of rhodamine B is actually made up of 2 moles of nitrogen. Okay? So, yun yung conversion factor na kailangan natin. Okay? So, 2 moles of nitrogen divided by 1 moles of rhodamine B. Okay, now, pwede na natin i-cancel yan. Okay? Diba? Pag nagsusolve tayo with units, alam natin agad kung may mali. Okay? Now, finally, okay, from moles, okay, to the atoms or molecules, kailangan natin yung Avogadro's number. Okay? So, meron kang 2 moles of nitrogen dito, okay, times, okay, 6.02 times 10 to the 23rd atoms of nitrogen, okay, per 1 mole of nitrogen, okay? So, again na yung Avogadro's number, okay? So, mole nitrogens cancel, tapos meron kang atoms of nitrogen. Okay, now, at that point, alam mo na natapos ka na sa iyong calculation kasi yung unit, okay, yung unit yun ng final conversion factor mo is going to be the unit of what is required. Okay? So, pag inanong mo yung arithmetic, it's going to be 1.43 times 10 to the 22 atoms of nitrogen. Okay? So, okay, so paano natin malalaman na tama itong answer natin? Okay, so first and foremost, yung grams nakikita natin, di ba? You can see grams, but the atoms hindi. So ibig sabihin yan, okay, dapat yung atoms actually should be accompanied by a very big number, okay? So malala niyo last time, a small unit should come with a big number, okay? And then a bigger unit should come with a small number. Okay, so tandaan nyo yon. Okay, and then may another variation din ng problem na ito. Pwede rin na as teachers, pwede tayong mag-start from atoms or molecules, particles, tapos tanungin natin yung grams. Okay, so pag binaliktad natin tong flow chart na ito or tong concept map na ito, ang ibig sabihin niyan is babalik rin natin lahat. Kukunin natin yung reciprocal lahat ng conversion factors. Okay, so pwede nating i-try yun sa ating mga students. Okay, so that is our first problem. Okay, so simply weight, okay, going to the number of particles. May mga tanong po kayo? Any questions? Wala, medyo tahimik ata ang mga participants ngayon. Yung last na nag ako ang dami-daming nagtatanong or baka sa hulihan na lang. Okay? Okay. Now pumunta na tayo sa pagbabalik tanaw natin sa mga important na chemical concepts para sagutin natin yung second problem. Okay? Okay. Now, kung kanina, yung recipe natin ay chemical formula. Ngayon, yung recipe natin ay to a higher level na. So, yung recipe natin will be a balanced chemical equation. Okay? Para mas maintindihan ninyo, gumamit na naman ako ng analogy. Okay? Puro recipe. Ganun ang stoichiometry. Recipe. Sabihin nyo sa mga estudyante, kung hindi nyo finalo yung recipe, magiging palpak yung ulam. So, kaya, ganun din sa stoichiometry. Pag hindi finalo yung chemical formula, balanced chemical equation, magiging palpak yung sagot. Okay? So, ano yung recipe ng gulaman? Okay? So, say, gusto mong gumawa ng gulaman, pero again, dapat hindi pala palagi kasi potential na carcinogen yung dye ng gulaman. Okay? 36 cups of water. Okay? 3 cups of brown sugar and 1 cup of red gulaman powder. Okay? So, basically, itong gulaman, parang gelatin ito na may dye. Okay? So, yung water is going to swell, okay? The powder and then, of course, yung sugar. Kailangan yung sugar. Okay? So, yun yung recipe ng gulaman. Now, let's look at a balanced chemical equation. Okay? Tapos makikita natin from the balanced chemical equation, yung recipe, okay, ng mga reactants or products. Okay? And syempre, since stoichiometry ito, ang bida ay yung mole. Kaya, makikita natin mamaya yung mole ratio ng reactants and products. Okay? So here is an example of a simple balanced chemical equation. Okay? So 2H2 plus O2 to give you 2H2O. So this is the formation of water from its elements. Okay? So bakit nga ba balance to? Okay? So meron kang 2 times 2, 4 hydrogen sa left-hand side. Sa right-hand side, meron 2 times 2, 2 hydrogen. Okay? So balance yung H. Meron kang dalawang oxygen sa left-hand side. Meron kang yung dalawang oxygen sa right-hand side. So this is a balanced chemical equation. Okay? So katulad din kanina, di ba, nung pinag-uusapan natin yung chemical formula, meron tayong dalawang interpretation. Microscopic and macroscopic. So we are going to do a similar approach dito sa balanced chemical equation. Ano nga ba itong microscopic interpretation? Pwede nating sabihin na you have two molecules, sorry. Kung microscopic, hindi mo nakikita, so dapat molecules, okay? So 2 molecules of H2 will react with 1 molecule of O2 to produce 2 molecules of water. Ayan yung microscopic interpretation. Pero kadalasan sa stoichiometry, hindi mo naman ginagamit tong microscopic interpretation. Gumagamit ka ng macroscopic interpretation. So ano nga ba tong macroscopic? Okay? So instead of molecules, you could actually replace that with moles. So 2 moles of H2 will react with 1 mole of O2 to produce 2 moles of H2O. Okay, so yan yung recipe. Okay, so the balanced chemical reaction is a recipe. Okay? Okay, so kung kanina yung concept map natin sorry, medyo simple. Ngayon yung concept map natin is medyo mas complex na. Okay? So ano yung concept map natin for this for calculations involving balanced chemical equation. Okay? So mahalaga na first to get the correct balanced chemical equation. Okay? Okay, so kailangan muna yung balanced chemical equation. Again, pag hindi balance yung chemical equation, there is no way for the stoichiometric problem to be correct. So, ang gusto kong balanced chemical equation is ito. Okay, so CaC2 plus 2H2O to give you C2H2 plus Ca close open parenthesis OH2. Okay, so that's the balanced chemical equation. So the first thing na gagawin kung may stoichiometric problem is to balance the chemical equation. Okay, now sabi natin that the balanced chemical equation is a recipe, okay? And we are going to find, okay, the mole ratio. Ano nga ba tong mole ratio, okay? So since a balanced chemical equation means could be interpreted in the mole level, it means that we could get the mole ratio. Okay, so say itong balanced chemical equation natin could be read as 1 mole of CaC2, calcium carbide, okay, will react to 2 moles of water to give you 1 mole of C2H2 or acetylene and 1 mole of CaOH2 or calcium hydroxide. So anong example ng mole ratio? Pag sinabi mong ratio, it means a fraction, di ba? Tama ba ako? So mole ratio tells you is basically the fraction, okay? The fraction of the mole component of either the reactant or the product. So an example of that is, okay, say in this case, just an example. So 2 moles of H2O per 1 mole of C2H2, okay? So again, okay, pag walang numerical coefficient, it means 1, okay? So 2 moles of water per 1 mole of C2H2, okay? So that is an example of a mole ratio, okay? And pwede natin gamitin yung mole ratio in order to convert, okay, the moles of a known substance to the moles of the desired substance, okay? So we could actually get the relationship of all of the reactants and products, okay, using the mole ratio. Okay, so nung pinaprepare ko tong slide na to, I mean, pwede naman bigyan ko na lang kayo ng problem na, say for example, explicitly na ito yung number of moles, tapos ika-calculate yung relationship niya to one of the reactants or the products also given in moles. Pero inisip ko na dapat medyo bigyan ng spice yung problem, okay? So bigyan natin ng spice yung problem, okay? So why don't we say for example use, okay, the ideal gas equation, okay, in this type of problems. Kasi pwede naman ninyong malaman yung number of moles in a given say for example gaseous species, okay, by simply applying the ideal gas equation. So ano nga ba tong ideal gas equation? So PV equals nRT. P is pressure in atmosphere. V is volume in liters. Yung N, okay, ito yung gusto natin, number of moles, okay, number of moles. So, pwede in our problem, meron tayong gaseous species and then i-calculate natin yung number of moles, di ba? Tapos, yung R is the gas constant, 0.08206 liter atmosphere per mole Kelvin. And finally, yung temperature natin, which actually must be expressed in Kelvin. Okay? So, yung problem na makikita nyo mamaya, kukunin muna natin yung number of moles ng gas, tapos i-relate natin to one of the reactants. Okay? Okie dokie. Okay. Saglit lang. Okay. So ito yung problem na gusto kong i-discuss sa inyo, okay? So syempre, katulad ng parol, I mean meron din yung problem natin ni-relate ko sa ngayon naman New Year, okay? So may Christmas tayo, yung parol, tapos ngayon may New Year tayo, okay? The following reaction is used to generate acetylene, okay? That will be ignited for bamboo cannons, okay? So CaC2, calcium carbide, ito yung tinatawag na kalburo, okay? Plus 2 water, okay? So pag gumagawa sila ng bamboo cannons, okay? Binubuhusan nila ng tubig yung kalburo. So that actually generates C2H2 acetylene, which is going to be ignited to give you that fire. So magbibigay siya ng parang anon effect, okay? And then the side product is calcium hydroxide, okay? So calculate the amount of water in grams needed to react with excess calcium carbide to produce 10 liters, okay? 10 liters of C2H2 at 1 atm and 25 degrees Celsius, okay? So hydrogen is 1.008, oxygen is 16.00. Okay. So ano yung approach natin dito? Okay? So yung approach natin is first gagamitin natin yung balanced chemical equation. Okay? So ano yung balanced chemical equation natin? CaC2 plus 2H2O to give you C2H2 plus Ca close open parenthesis OH2. And from the balanced chemical equation, makukuha natin yung mole ratio. So, ano nga itong mole ratio natin? So, moles, okay? Moles of desired substance divided by the moles of known substance. Ano yung desired substance natin? Isn't it? It's water kasi the problem says calculate the amount of water in grams. So, yun yung gusto nating makuha, okay? So, yun yung required. So, yung required will be actually on the numerator of your mole ratio. Tapos, yung moles of known substance natin, okay? Well, in this case, hindi talaga known kasi kailangan mong i-calculate, okay? Pero makakalculate natin, makakalculate natin from the PV equals nRT, okay? So, and that's going to be your gaseous species, okay? C2H2. Again, I have to tell you that, okay? So, yung reactants natin solid, liquid, and then meron kang gas, solid sa product. So yung PV equals nRT ginagamit lamang sa mga gases, okay? Okay, so yung known substance natin, okay, is going to be acetylene, C2H2. So yung mole ratio natin will be 2 moles of water per 1 mole of C2H2. So yun yung mole ratio natin. Okay? Tapos gagamitin natin yung mole ratio to convert the moles of the known substance. Okay? So, since hindi mo agad makukuha yung number of moles from this equation, we need to actually rearrange it. Hindi po ba? So, kailangan natin i-rearrange. Okay? So, it's going to be N equals PV divided by RT. Okay, so it is going to be the moles of C2H2. Okay, so moles of C2H2, you use the mole ratio in order to get the moles of the desired substance, which is water. Okay, so in-outline ko ulit yung steps dito. Okay, so we need to get the moles of gas. Okay, so moles of the gas, which is essentially you're given. Okay, using the mole ratio, and then we could get actually the amount of water which is your required. Again, yung R sa equation natin, PV equals nRT will be 0.08206 liter atmosphere per mole Kelvin. Okay? Before ko i-discuss yung solution na ito, I would just like to give you some a little of reminder. Pag ginamit natin yung PV equals nRT, and alam natin yung R has actually the units of LATM per mole Kelvin, kailangan, okay, that your volume must be in liters, which is correct. Meron tayong liters dyan. Tapos yung atmosphere natin must be yung pressure natin must be in atmosphere. Meron ka do you have atmosphere? Yes. Tapos yung temperature natin must be in Kelvin. Oops, okay? Kailangan natin i-convert yan to Kelvin. Okay, so we could simply convert degrees Celsius to Kelvin by adding 273. Okay, so that's going to be 298 Kelvin. Okay, kailangan. Tawag doon, dimensional homogeneity. Okay, so hindi mo po pwedeng gamitin yung equation na yan hanggat, okay, yung volume should be in liters, pressure in atmosphere, and then temperature in Kelvin. Requirement yon. Okay, isolve na natin yung problem. Okay, so moving on. So we have I have shown you the rearrangement already. So N is PV over RT. Okay, so pressure is 1 atm. Pressure is 1 atm. Volume is 10 liters. Tapos yung R is 0.08206. And then yung temperature natin must be converted to Kelvin. So kung titignan natin, okay, yung atmosphere naka-cancel, liters naka-cancel, Kelvin naka-cancel, you are going to have actually moles. So 1 divided by 1 over moles will be moles. Okay? So you have 0.4089 moles of C2H2. Okay. Now, yung next natin na gagawin is we need to convert these moles to what is required, which is water. And we can only do so by using the mole ratio. And the mole ratio will be coming from the balanced chemical equation. Okay? So we start with 0.4089 moles of C2H2. Then meron kang mole ratio. Okay, very important because it's important to cancel the given here. Okay, so mole C2H2. So dapat yung mole C2H2 nasa ilalim, nasa denominator. Tapos yung required mo, which is water, dapat nasa numerator. And again, meron kang 2 moles of water per 1 mole of C2H2. Saan natin nakuha yung mga values na yon? Dito. Okay? So 2 moles of water per 1 mole of C2H2. So kailangan talaga na correct yung balanced chemical equation. And then finally, since ang tinatanong sa problem is actually in terms of grams, okay? Sorry, actually kagagaling ko lang sa COVID kaya I keep on coughing. Okay? Okay, and then finally, i-convert natin yung moles, okay? So may moles water dito into grams water kasi yun yung tinatanong sa problem. Calculate the amount of water in grams, okay? So water alam na is we could solve the molar mass quickly. So 2 times 1.008 plus 16 is going to be 18.016. Okay, so moles water cancels out and finally you have grams of water. Okay, so that's about 15 grams of water. So, anong ibig sabihin nito? Okay, so kung gusto mong say, yung volume ng acetylene is about 10 liters, which is about the volume of this bamboo cannon. Okay, so kung gusto mong to have that effect, okay, kailangan mong lagyan ng about 15 grams, about 15 ml, kasi intensity of water is 1 gram per ml. Kailangan mong lagyan ng 15 ml yung excess na karburo para pasindihin tong bamboo cannon na ito. And then, of course, the kids will be very happy. I mean, and shout Happy New Year, diba? Yeah, gusto ko talaga yung ganito. I mean, pag nagbibigay tayo ng problems or what, something na makaka-relate yung mga estudyante. Hindi yung tipong magbibigay tayo ng problem na very abstract. I mean, lalagay natin an unknown chemical of this blah blah blah. Hindi. I mean, we should actually go beyond those types. Okay? Any questions? Any questions? Kung hindi, pupunta na tayo sa third problem natin. Wala? Okay. So, okay. So, ang gagawin ko ngayon is actually, I'm going to give you a variation. Okay? So, syempre, kung teacher tayo, gusto na natin may variation yung problems natin. Hindi naman katulad yan sa bahay. Kung say for example, kunwari, I mean, puro adobo na lang yung inuulam natin. Syempre, mauumay na tayo. Gusto na naman natin yung variation. Okay? So, siguro adobo ngayon, tapos bukas, I mean, kailangan, kakain naman tayo ng gulay. Okay? So yung problem na diniscuss ko kanina is actually may keyword na ginamit doon. Okay? So i-review natin. So kanina yung after ng balanced chemical equation, it says calculate the amount of water in grams needed to react with excess calcium carbide, okay, CaC2. So, may keyword. Okay, yung keyword na yun ay excess. Okay, bakit kailangan yung keyword na yun? Okay? Kasi sa stoichiometry, yung product na na-obtain natin will always be based sa limiting reactant. So, pag sinabing excess calcium carbide, CaC2, so ito yung excess, dadalawa lang naman yung reactant. So, ibig sabihin, yung limiting reactant mo will be your water. And water is the one that's going to determine, okay, the amount of the product that is formed. Again, okay, the products will always be based from the limiting reactant. Okay, the problem that we have actually discussed a while ago, it explicitly says kung ano yung excess. Okay, so ibig sabihin, by default, yung other reactant is going to be limiting. Okay, so kaya yung water ang ginamit natin, I mean to actually relate yung amount ng product, which is C2H2. Okay. So in order to give a variety, okay, so kukuha naman tayo ng problem ngayon na say for example, hindi natin sasabihin kung ano yung excess, okay? So we are going to actually have another variation of stoichiometric calculation by which, okay, the student will be the one to see alin nga bang excess. I mean, yung reactant A or B. Alin nga ba yung limiting. Okay? So, yun yung pagtutuunan natin ng pansin sa last problem. Okay? Okay. So, concept of limiting and excess reactants. So, tanda ko pa noon college kami, I mean, college ako. yung first na experiment na ginawa, one of the very first experiment na ginawa namin is actually nuts and bolts. Okay? So nuts, so itong may screw na ito, tapos yung bolt, parang hex nut, parang i-pair mo. So ano nga ba itong limiting or excess reactant na ito? Okay? So say for example, meron kang dalawang bolt, tapos meron kang 1, 2, 3, tatlong nuts. So nuts and bolts. So alam natin yung pairing is kailangan meron kang isang bolt tapos isang nut. Okay? So kung meron kang dalawang dalawang uh, dalawang uh, dalawang dalawang screw na ito tapos meron kang 1, 2, 3, tatlong nuts. So, ibig sabihin, you can only have 2 pairs, right? So, ito is going to be in excess. So, what's going to determine the number of pairs will be the one that has actually that's going to be less. So, say for example, tong screw na ito. So yan yung concept ng limiting and excess reactant. So i-modify natin yung chart kanina. So instead of, just saying moles of the given tapos moles of the product. So sabihin natin moles of the limiting reactant. Okay? So sa variation na ito, hindi sasabihin kung ano yung excess. So hindi natin alam. So since mas maraming sekreto ito, we are going to do 2 rounds of calculation. Okay? Tapos titignan natin titignan natin which one will give the lower the lower the lower product amount of the product. Okay? Okay. Siyempre, gagamitin ko ulit yung illustration ko. Okay? So, kunwari, gagawa tayo ng parol. Okay? So, alam natin na yung recipe ng parol. Isang star, isang rate, tapos dalawang tails. Okay, so ito yung preliminary problem ko. Okay? What is the maximum number of paroles? Ginawa kong in English ko na, I mean paroles that can be made with 8 stars, 7 rits, and 20 tails. Okay? So, ang gagawin natin dito, okay, since hindi naman sinabi kung ano yung excess or limiting, I'm going to actually do multiple rounds of calculation, okay? So, in this case, it's going to be 1, 2, 3 rounds, okay? So, kung meron kang dalawang reactants, 2 rounds. Kung meron kang tatlong reactants, 3 rounds, okay? Dalawang reactants, 2 rounds. Tatlong reactants, okay? 3 rounds, okay? So, we'll start. So, gagawin natin is we are going to calculate the number of parol that could be constructed, okay, from 8 stars. Okay, so 8 stars times 1 parol per 1 star. Bakit? Because of the recipe. 1 parol for 1 star. Okay, the stars will cancel. You're going to get 8 parol. Okay. Now 7 reeds. 7 reeds times 1 parol per 1 reed. Again, recipe. 1 parol, 1 reed. Reeds cancel. Meron kang parol. So 7 na parol. And then finally, meron kang 20 tails. Okay, so 1 parol per 2 tails. Okay, so meron kang 10 na parol. Pero ano nga ba? I mean, ano yung maximum number na pwede mong ma-create? Okay, so in order to do that, we are going to find the lowest, okay? The lowest number in the set of calculations. So 8 parol, 7 parol, 10 parol. So ang pwede mo lamang magawa ay actually 7 parol. So it tells you that the reed, okay, is the limiting reactant or the limiting ingredient, okay? Limiting, kaya nga limiting, ililimit niya yung product to a certain extent. Okay? So that is my analogy, okay? And then we are going to get some review and then we are going to discuss the final problem. Okay? So review, I would like us to review the concept of molarity and precipitation reactions. Ano nga ba tong molarity na ito? Okay, a molarity is actually, or molar is actually a unit of concentration. Okay, so say for example, okay, kunwari, meron kang 1 liter na volumetric flask. 1 liter na volumetric flask. Okay, so kung tandaan nyo pa, I mean, yung volumetric flask may marker. Ang ibig sabihin yan, yung volume ng solution, okay, until that marker is actually 1 liter. Okay? So, kung meron kang, say, meron kang 0.2 moles, kunwari. May 0.2 moles ka na nilagay. Okay? Sa volumetric flask. Tapos, lalagyan mo siya ng tubig up to the 1 liter mark. Okay? So, ibig sabihin yan, meron kang 0.2 moles, okay, of that substance per 1 liter of the solution. Okay? So, 0.2 big M, or we could say moles per liter. Okay? Yan yung concentration ng solution mo. I also would like na i-review natin yung concept ng precipitation. Okay? Usually a precipitation, a precipitate comes from a double displacement reaction. Okay? And a precipitate is actually an ionic compound that is sparingly soluble. Okay? So hindi siya natutunaw. Like, anong example nito? Say yung salt, table salt, natutunaw siya, so you don't call it precipitate. So if you are familiar with milk of magnesia, say magnesium hydroxide, hindi ito actually na natutunaw. Okay, so sparingly soluble, so you could actually think of that as a precipitate. So precipitation reactions, or the generation of precipitates, usually come from a double displacement reaction. So ito yung schematic ko. So double displacement. So parang nagpalitan ng partners, okay? So the example that I will use is the reaction of lead chloride and sodium carbonate to give you lead carbonate and sodium chloride, okay? So kinolor code ko yung mga elements. So nakikita nyo na may swapping, okay? In between sodium chloride and lead carbonate is going to be your precipitate. Okay, before I move on, usually ang ginagamit natin is the solubility rules to determine, which is going to be a precipitate, but I'm going to share a very quick way, okay, to determine that, okay? Say lead carbonate. So ano ang charge ng lead? +2. Multiply that to the charge of carbonate, which is -2. Then take the absolute value. It's going to be 4. Okay? Versus, okay, sodium chloride. So that's actually +1 for sodium, -1 for chlorine. Take the product and then get the absolute value 1. So 4 versus 1. So usually yung mas mataas, okay? Mas mataas na value, that would actually tell you that it's more likely to be the precipitate. So the precipitate is going to be the lead carbonate. Okay? Okay. Okie dokie. So nasa final problem na tayo. Okay? Baka nagugutom na kayo, kailangan nyo na magmerienda. Don't worry, malapit na tayong matapos. Okay. So, ito, may trivia na naman ako sa inyo. Okay? So, old Philippine mansions were usually painted with lead carbonate. So, kung nakakita kayo ng mga lumang bahay na bato, usually napinturahan yan ng lead carbonate. Okay? Wag niyo pong didilaan. tong white na paint kasi they are actually sweet but very poisonous kasi may lead siya. Okay? So lead carbonate is produced by the reaction of lead chloride and sodium carbonate. So i-interpret natin tong reaction na ito. So 1 mole of lead chloride will react with 1 mole of sodium carbonate to give you 1 mole of lead carbonate and 2 moles of sodium chloride. Okay, calculate the maximum amount of lead carbonate in grams that can be made from 0.1 liters of 0.70 molar lead chloride and 0.15 liters of 0.5 molar sodium carbonate. Okay, so yun yung first na question, follow-up question. If the percent yield is 92%, then what is the actual yield? The molar mass of lead carbonate is 267.2 grams per mole. Okay, now, ihalin tulad natin sa previous problem. So, meron ba kayong nakikitang the word na excess? Wala, di ba? So, hindi niya sinabi kung ano yung excess. So, therefore, hindi nyo may infer kung ano yung limiting. So, binigyan kayo ng two sets of values. Okay? So, ang gagawin natin is we are going to do 2 rounds of calculation. Okay? So, this is variation number 2. Hindi sinabi sa problem kung ano yung excess. Okay? So, yan yung difference na with the previous problem, hindi sinabi yung excess. So, ang gagawin natin, we are going to do 2 rounds of calculation. So, we are going to do the calculation okay, as if, okay, yung lead chloride natin is the limiting reagent, and also do another set of calculation as if the sodium carbonate is the limiting reagent. Tapos, i-compare na lang natin yung values nila. Whatever will give us the lower, okay, the lower value for the product will be your limiting reagent, okay? Okay, so ito yung schematic natin. So meron kang hindi mo alam yung most of limiting reactant, okay? Yung lead ba or yung carbonate ba? So we are going to do 2 rounds of calculation, okay? Ika-calculate natin yung amount, yung possible amount ng lead carbonate that could be formed from lead chloride, and then the second round is the amount of lead carbonate that could be formed from sodium carbonate. Okay, so ito na. Okay, so 2 rounds of calculation kasi hindi sinabi kung sino yung excess. Okay, so we need to actually again do unit analysis dito. Kanina sinabi ko na yung big letter M is equal to moles per liter. Okay? Okay? Now, since sino nga ba ang bida sa stoichiometry, hindi ba moles? Okay? So in order to actually convert that unit into moles, we need to actually multiply that to liters, di ba? Para magka-cancel yung liters, then you're going to get moles. Okay? So pag nakakita kayo ng pag nakakita kayo ng value na may molarity at saka liters, i-multiply nyo dapat automatic na i-multiply nyo sila. Okay? So 0.1 liters of 0.7 molar lead chloride. Okay? So 0.1 times 0.7. Bakit multiplication? Para ma-cancel yung liters, di ba? Okay? Now next, okay? Meron kang lead chloride, kailangan mong i-relate doon sa product mo. Now we can only do that if we use a mole ratio. So 1 mole of lead carbonate per 1 mole of lead chloride. Okay? So moles lead chloride will cancel. Meron kang moles of lead carbonate. From the problem, given na yung molar mass ng lead carbonate, so i-multiply na lang natin sila. Okay, so you have grams of lead carbonate. Kung meron kang 0.1 liters of 0.7 molar lead chloride, you are going to form 18.7 grams of lead carbonate. Okay, now, sabi ko kanina, since wala yung word na excess, we need 2 rounds of calculation. So you have 0.15 liters times 0.5 moles sodium carbonate per liter. So liter will cancel out. And then we need the molar ratio or the mole ratio. So 1 mole of lead carbonate per 1 mole of sodium chloride, okay, which is from the balanced chemical equation. And then finally, moles of lead carbonate to grams of lead carbonate using the molar mass. So meron kang ngayong 20 grams of lead carbonate. Okay, now, the amount of product that will be formed in reality is the one that will actually that 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 is the this is the the lesser number sa calculation natin. Actually, this calculation has a special name. It's called the smaller amount method. Okay, so smaller amount. So 18.7 is actually smaller than 20 grams. So yung product na makukuha natin, yung maximum yield from the reaction is going to be 18.7 grams. Kaya tinawag na smaller amount method. Okay? Okay. And then finally, hindi pa tayo tapos kasi may follow-up problem. Okay? The problem as ano yung actual yield if the percent yield is 92%. Okay? But before we get into that, I would like to discuss, what a percent yield is. So ano nga ba itong percent yield? So kadalasan ang chemical reaction hindi 100% efficient yan. So swerte ka na kung meron kang at least 80%. Kung hindi ka naman papalarin, baka you can have 60% or 40%. Okay? So percent yield is actual yield divided by the theoretical yield, or the theoretical yield is the maximum yield, okay, times 100. So to give you an illustration first, kunwari may pitong itlog, okay? So 1, 2, 3, 4, 5, 6, 7. Kunwari, dalawa lang ang na-hatch, okay? So yung actual yield mo is 2, okay, divided by 7, which is the maximum possible. So in this case, you only have 28.6% hatch, okay? So since yung problem asks us to determine the actual yield, okay, given a percent yield, alam natin yung theoretical yield or the maximum yield, yung 18.7 K times 100. So we could actually rearrange the equation, okay, above to determine the actual yield. So actual yield will be the percent yield divided by 100 times the maximum yield, okay? So the actual yield in this case is going to be 0.92 times 18.7, so 17.2 grams or 17 grams. So yun lang yung pwede mong makuha. So again, the actual yield should always be less than the maximum or the theoretical yield. Okay? So, summary, okay? So ito yung napag-aralan natin ngayon. So again, I would suggest that in solving stoichiometric problems, teachers will use flow chart kasi mas madaling makita, is very visual. So yung unang problem, nakita natin yung conversion of grams to moles and then moles to the number of particles using Avogadro's number. Tapos yung second problem, specifically minention yung one of the reactants are in excess. So alam natin yung limiting, and then agad natin na-determine yung amount of the product. Okay, pero yung second variation, hindi sinabi kung ano yung excess. Okay, pag hindi sinabi kung ano yung excess, therefore we are going to do 2 rounds of calculation, and the one that's going to give us the smaller amount is going to be the limiting reactant. And the limiting reactant is the one that will always determine the amount of the product that will be formed. Okay, so thank you for bearing with me. Pasensya na kayo, medyo nagka-cough ako. I mean, don't worry, hindi naman kayo na mahahawaan kasi kasi naka-zoom naman tayo. So, ngayon I think it's already time to ask questions. I mean, sagutin na natin yung mga katanungan na meron kayo during the presentation.
Alright, so maraming salamat po Sir Chester para po sa pangalawang installment ng Chemistry Essential Skills. So, siguro ako po, I was very happy to see kung paano po ito talaga dinisenyo ni Sir Chester yung lecture. He didn't only just like focus on stoichiometry as a topic. So kung napansin niyo po, ang dami po niya mga basic concepts din in chemistry na in-unpack, like percent yield, for example, theoretical yield. So ito pong mga bagay na ito, kung mapapansin nyo po, nagbe-build up po yung mga konsepto na binubuo natin, na tinatakal natin sa simula ng chemistry for us to be able to tackle more complex topics like stoichiometry. And yun po yung pinakita sa atin ni Sir Chester. Ayan. And kung babalikan niyo po yung first installment of this webinar series, he introduced the concept of visualization. So I'm hoping that for the teachers who are participating in this webinars series, sana po yun nakukuha nyo ding best practice na mas madali pong mapaintindi sa mga estudyante yung konsepto sa chemistry if you know how to visualize it. Medyo wag na po natin masyadong gawin yung word problem and then memorize mo lang ng steps ng pag-solve ng problem kasi hindi po masyadong transferable yung ganoong approach. So gaya ng pinakita ni Sir Chester. All right. So we would encourage for you all to ask questions. So whether it be from Zoom or YouTube, ang value po talaga nitong mga ginagawa nating webinar series, ang hahatid namin sa inyo ng mga ekspertong kaparehas ni Sir Chester. Ayun pong mabigyan kayo ng pagkakataon na magtanong at masagot po ang inyong mga agam-agam, ang inyong mga katanungan. Ayan. So wag po kayong mahiya. We're monitoring questions po from both Zoom and YouTube. Right? Meron po ba dito mga tanong? Ayan. Nag-comment si Mama Connie. Ang sabi niya, ang galing. Ayan, ang galing daw, Sir Chester.
Salamat po, Mama Connie.
And then, by the way, ang dami po natin nag-dial in sa YouTube, by the way. So, ayun. So, and kung mapapansin niyo po si... Yes. Yung kung mapapansin niyo po, actually may head kakagaling lang sa COVID ni Sir Chester, kung napapansin niyo po nauubo pa. And then si Mama Connie, she's dialing in from San Antonio here in Texas. Siya naman may masakit ang ulo.
Oh.
Ako naman po isang linggo walang tulog. Galing ako sa isang conference, so I barely slept.
Tignan mo yun. Mahal na mahal namin ang mga Philippine students.
Opo, mahal natin ng Pilipinas.
There's a lot of COVID in my lab, so I hope I'm not going down with something too.
Yeah, you're going back home in 2 weeks, so
I know.
don't catch anything para you can enjoy your vacation. So ayan, may mga tanong po ba kayo? Mukhang medyo mahihiyain ang ating audience ngayon or ano ba sila? Handa na ba para sa lunchtime?
Ako, Sir Chester, kung sana noon ikaw ang teacher ko, di ang dami ko sanang naintindihan chemistry.
ako Mama, I had the privilege of being taught by
Sir
Chester sa UP. Si Sir Chester
po, so lucky.
Si Sir Chester po ang aking teacher sa organic chemistry laboratory courses ko sa UP.
Wag mo na i-mention.
Ayan.
Oo, kasi alam mo naman, lahat naman, well, yung batch ko, lahat kami takot sa chem.
Yes.
Syempre, kailangan namin kasi pre-med kami at saka biology, di ba? Kailangan namin yun.
And you raise a very important point, Mama Connie, kasi just like math, kasi
Exactly.
ang dami mga estudyante, past and current generation, na nadi-discourage na mag-aral ng math or ng chemistry mainly because ang pag nabanggit na chemistry parang ay ang hirap niyan, ay ang daming math, ang daming magme-memorize ako ng periodic table. Pero sa totoo lang po, well, in fact, yung mga magagaling na chemist, they don't memorize.
They don't.
Opo,
Kaya nga critical talaga ang teacher, ang professor
yes,
talaga.
yes. So, ito pong tinuro sa inyo na Sir Chester, i-review niyo po to, ipapanood niyo po to sa mga estudyante niyo kasi ito na po talaga yung pinaka basic na
Mhm.
pinaka-democratized na paraan ng pagtuturo ng chem. So, kung napansin niyo po, how we started the concepts was he was using commonplace analogies. So, napansin niyo po yung nut and bolts. How can it be simpler than that? Kita niyo po yung pag-assemble ng parol. Kung gagamit po kayo ng ganong analogies to teach stoichiometry, ang dali pong ipaliwanag sa mga estudyante niyo. And I also have to say, Sir Chester spent weeks po conceptualizing kung ano ba yung analogies na gagamitin niya para maging relatable po talaga. So, we truly appreciate po yung pag-dial in ninyo sa session natin ngayong araw na ito kasi talaga pong ito po yung nakukuha na namin ng sense of inspiration na that you truly care about learning how to teach these topics most effectively kasi hindi po talaga siya madaling ituro. And then again, kapag hindi po solid yung basics, kapag hindi solid yung dimensional analysis, kapag hindi po solid yung visualization nyo ng problem, yung pag-unpack ng problem, which Sir Chester tackled dun sa first session. Sa mga hindi po nakapanood ng first session, balikan nyo po yun. Kasi yung po mga ginamit yung mga strategies, techniques, and best practices sa webinar na ito, hinimay niya po yun nung
Yeah,
kasimula.
they should go back to that video though.
Yes, yes.
Yeah.
And ito po, ang babanggitin ko lang din po sa inyo. So, itong session na to is on quantitative skill. Ito po, medyo madali pa kasi you can associate numbers, you can calculate and then you have an answer. Ang pangatlo pong skill na i-deliver namin sa inyo is abstract thinking naman. So, paano nyo ba gagamitin yung imagination nyo para maintindihan nyo yung behavior ng atoms, yung behaviors ng molecules? Yung abstract thinking na po yan naman, i-apply natin in the context of quantum chemistry. So si Sir Chester rin po ang maghahandog nun sa inyo. Ipa-finalize pa lang po namin yung date, pero more likely it's gonna be December 15th in the Philippines. So kalagatian, yan po yung maagang pamaskong bigay namin sa inyo. At alam din po na namin na napakarami pong takot na takot din sa quantum chemistry. Ayan. Magbasa muna tayo ng feedback habang wala pang tatanong. Sabi ni Sir Dean Clifford, ni Ma'am Donna Emmanuel, salamat po, well explained po siya. Kaya pala wala nagtatanong. Ayan. Yes, Sir Dean Clifford, Joanne, galing ng pagka-discuss ni Sir. Sulit talaga na maaga na ako nag-end ng class ko para maka-attend ng session ngayon. We truly appreciate it po. Ayan. And this is Sir Cliff Florentino, thank you for the strategy of simplifying like recipe. Challenging po ang topic na stoichiometry. Alam niyo po yung po talaga yun. Recipe. So may pagsusukat po. Pag sumobra, alam niyo po, hindi naman siya, hindi dapat yung chemical reaction saktong-sakto po kasi talaga sila nangyayari, 'di ba? So hindi po pwedeng kalahati lang, ganyan. So kapag hindi nasapatan yung requirement, edi excess na yun. Ayan. Sa ano naman po, sa YouTube naman, sabi ni Ma'am Melanie Bicas na madalas po nating viewer rin po and supporter. Very clear an explanation ni Sir Chester. Thank you very much po. And then may mga students na rin po ako na na-inspire na mag-take ng Bachelor of Science in Chemistry at professional na rin po sila. Ay, maraming salamat po. Alam mo yan po talaga siguro ang truest sense ng ng pagtuturo rin ng STEM kapag po ang mga estudyante nyo ay talaga pong nakumbinse na mag-pursue ng career sa area po kung saan po ninyo sila na-inspire. Siguro po yun po yung isa na talagang sa matatawag nating best or truest realization ng mga misyon natin sa buhay. Ayan po. Meron pa po ba? Meron pa po ba? Wala po ba talaga sa inyo magtatanong? So, siguro ganun talaga kaklaro, Kuya Chester. Ayan. Hindi, pero yun po, kung napansin niyo po, relatable yung mga examples. Yung context po talagang maiintindihan nyo. At alam nyo po, hindi lang po doon. May layer pa po yan ng pagiging makabayan. So kung mapapansin nyo po, yung mga analogies na ginawa ni Kuya Chester ay may elemento rin po ng kulturang Pilipino. At kung hindi nyo po napapansin, ang kanya pong suot, anong tawag dyan, Kuya? Batik.
Batik, di ba?
Yan. So, ang atin pong pagiging makabayan ay hindi po natin kinakalimutan. Alam niyo po kanina, ako po as a student and as a very good friend of Kuya Chester, I was beaming with joy and pride to see someone like him who started in the Philippines. Yung kanya pong academic training, hinubo yan sa Europa at sa Amerika, and then napakaraming taon na po ang kanyang ginugol ng pagtuturo. So nung nakita ko na po yung mga analogies na ginagawa ni Kuya Chester, para nakaka-proud po na this is essentially the crystallization of yung years of training and his experience as a teacher. Ayan. So maraming salamat po, Sir
Hindi
Chester.
madali yun.
Ay, opo, hindi po siya madali. Sa totoo lang po. And siguro po ang ako po, personally, ang paniniwala ko, yung tao po talagang naiintindihan ang ginagawa niya ay yung kaya pong gumawa ng pinakasimpleng pagpapaliwanag ng mga konseptong itinatanong sa kanya or kanyang itinuturo.
Alam mo yung Occam's razor?
Ay, hindi po, Mama.
Ano po yun, ma'am?
Ano po yun?
Yung pinakasimpleng explanation, yun yung tama.
Oh.
Yes. Totoo po yun. Ayan. Okay, anyway. So, mukhang wala nagtatanong. Pwede po ba kami mag-request sa mga kasama natin sa Zoom? Pwede po ba kaming mag-picture naman tayo para meron naman po tayong remembrance? I think majority of our audience members dialed in through YouTube. Baka hindi po sila makapag-Zoom ngayong araw na ito. Pero if it's okay po with all of you, mag-ano naman po tayo, mag-class picture naman tayo. Hindi naman tayo masyadong marami ngayong araw na ito sa Zoom.
Oo, pakita na kayo, mga beauties and mga pogi.
And then we would like to thank lahat po ng ating viewers sa YouTube. Ayan. Binabasa po namin lahat ng inyong mga feedback. So sabi ni Ma'am Sofia May Bacos, thank you po Sir Chester. Very comprehensive po talaga. Ang dami kong natutunan. Alright. Okay po. So bibilang po ako ng 5. Yung mga gusto po, meron po sa inyo gusto pong humabol ng camera. Alright. 1, 2, 3, 4. Ito pa po. Sabi ko hanggang 3 lang pala. Umaabot ako ng 4. Kaya pagpasensyahan nyo na. 1, 2, 3. Ayan. Okay, so I sent po the attendance form sa Zoom chat box at saka po sa YouTube Live. Ayan, muli. Maraming salamat po sa inyo at magkita-kita po tayo sa session 3. Abstract Thinking Applied in Quantum Chemistry. Alright? And we hope that you enjoy your lunch. Maraming salamat po. Ayan. Kuya Chester,
Chester.
Salamat po, Tita Connie, for all of the support.
Ayan.
Oh, naku, enjoy ako kasi hindi ako nag-enjoy